Welcome everybody to Pre-Calc today. We'll be learning about rational expression operations such as multiplying, dividing, adding, subtracting, except it's much easier to multiply and divide than it is to add and subtract in this. So we're going to start with the multiplying, dividing. So the key thing here to do is for all of these is to factor first. Factor first. So looking at number 1, I want to factor absolutely everything that I can. So what can I factor this top left? What's the GCF? A 2x squared. So 2x squared, and what's left on the inside? X minus 4? Or 4 minus x? 4x. I'm trying to listen to you people. Okay, very good. What about that bottom left one right here? X plus 4, x plus 2. What about this top one right here, top right? And what about this one down here? X 4x minus 1. This is where I get like lots of questions like, which ones can we cancel? Top and bottom cancel. Does diagonal cancel? Is it one on the top, the one's on the bottom? Yes. Then it cancels. I'm mimicking my Algebra 2 students that I taught years ago that were so confused. Wait, they're diagonal, they don't cancel. Well, is one on top and one's on the bottom? Yeah. Then it cancels. I don't care if it's diagonal or not. You cannot cancel on the same side. Okay? It's like friendly fire. I don't know really how, if you're playing a video game. I don't know if this is an approved message. But if you're like playing like a video game or like laser tag or whatever, and there's something called friendly fire on, that means you cannot get rid of your teammate. You can only get rid of the people on the other side. This is friendly fire. You cannot cancel out on the same side. You can combine them and make them bigger and stronger. You cannot cancel them out on the same side. You had a question, comment, concern?
Well, when you say same side, you mean top and bottom, not left, right?
Correct. Like, this is on the same, so these, I only care about top and bottom. I don't even care about left and right. To me, you can even switch these numbers up left and right because of the commutative property. It doesn't matter. Top and bottom, that's all I really care about. So you can't, top can't cancel with top, bottom can't cancel with bottom. Okay? Only top and bottom cancel each other out, even if they're diagonal. Okay, so with that being said, that little rant of mine that might have been completely useless, because maybe you all know how to do math unlike my other people. That's right, but they're not going to listen to this. Who at HP would listen to this? He's making fun of us, so I made fun of you, and I thought there too. So, don't worry, I'll make fun of you all at some point. I like to be even. Like when I teach calculus, I'm pretty sure I make fun of you people. I know, but the only problem is I have no one to make fun. I usually make fun of my calculus people when I teach multivariable calculus. But I don't have that, so I can't make fun of them. It's upsetting to me. All right. Anyway, what are we doing? Math? Okay. Hey, let's cancel this stuff out. Let's cancel this out. I heard x plus 4. Bam! Bam! 4x minus 1. Bam! Bam! What about my single terms? I have an x squared on top and an x on the bottom. I have 2 x's on top and 1 x on bottom. So I should just have 1 x left. So now what's on the top? What's left? All over? Okay, some people are like, I'm going to distribute. Don't do that. You do not need to do that. Just leave it. Stop doing more work than you're told. Okay. Let's look at number 2. Is there anything to factor? No, because they're all just expressions. Okay, so I can break this one down to be super simple, or I can just go through it really quick. It's your call. Really quick? Alright, so, does anything cancel out with an 8 from the bottom? Can I reduce the 8 with one of these numbers? How can I reduce it? Make it into a 4? If I do what? 8 and 12? I think we can do more than that than a 4, though. So, 8 goes into 12. So if it was like 8/12, what fraction would you write? What's 8/12? It's 2/3, right? So this 8 cancels out with that 12. This becomes a 2. This becomes a 3. Okay, because you can divide 4s out of each of those. What are my x's right here? I have 3 x's up here. Not 3 x terms, but I have 3 x's. How many x's do I have on the bottom? Actually, I have 3 x's on the bottom here. Here's 1 x and there's 2 more. So this x to the third cancels out with all of these x's. Okay? Does this 14 cancel out with anything on the bottom or reduce down at all? So 14 and 26. What divides into 14 and 26? Not 7. No, 7 doesn't go to 26. Good try, though. 2. So if I divide this by 2, this becomes a... And this becomes a... 13 with the y's. I have 4 y's on top, 1 on the bottom. So the y on the bottom's gone, and on the top I'm left with y to the third. I did all my canceling out. I can just multiply nicely, and I'll be good. So what is 2 times 7? 14, y to the third all over. Fine. We will be having a skills check on this next class, by the way. If you don't like it, you can drop this class. Do you want to try 3 on your own? Or do you want me to walk you through it again? Alright, you can do it. Let's find out. We're going to find out. Well, you'll find out. Let's see here. Just check over with mine as you're going through. That made it worse. A bit better? Is it blurry? Oh, okay. Alright, so let's finish up this problem. So what cancels out? Did I do something wrong?
Should that be x plus 4 and x plus 2?
This should be a 2 right here. Trying to see if you're paying attention. Okay, so it cancels out. X plus 3's. Bam. Bam. X plus 2's. Bam. Bam. X on top cancels out with the squared part comes away. So we're good? Final answer, x minus 1 all over 4x, x plus 4. Now if you wanted to, if you're like, can you distribute this? And if you distribute wrong, it's wrong. Well, you did it wrong. Why would I give you full credit for doing something wrong? Alright, so I always get these questions. Do I factor it more? Do I distribute? Just follow the directions right now. You leave it in factored form like this. It's fine. Okay, number 4. Do I really need to do that problem at all? Or can I move on with our lives? Move on. Okay, I don't see any value in that. Some of us don't have lives, I heard. I'm so sorry that you feel that way. Number 5, division. So for division, well, dividing fractions is as easy as pi. You flip the second and multiply. So dividing fractions is as easy as pi. You flip the second and you multiply. So all I'm going to do right now is just change this part up. So I'm going to change this into times and flip it. Because when you're dividing by 2, just think of any number. Like if you're doing like 8 divided by 2, isn't the same thing as times 1/2? So 8 divided by 2 is the same thing as 8 times 1/2. It's the same thing. Okay. So now let's see if I can break this down. What factors? 3x minus 1. Don't factor. Bottom left becomes 2x. You get x squared minus 1. And then this one up here becomes 2x. Well, I'm being very extra right here. Why even factor? That's a good question. Did I need a factor? It's the same thing. I was being very extra. Actually, I can be even more extra than that. Because does it actually factor even more? It does, but do I need to? No, because it cancels. You can't cancel out the x's, only the 3x. If you have another 3x minus 1, you can cancel. But I'll show you what you could do. Right, you cannot cancel those x's. That's illegal. You can only cancel full terms, or full factors, not like part of the term. Okay? Here's the reason why. I'm just trying to think of an example. Like 8 minus 3 all over 2. If I had this example, side note, what's this answer actually equal to? 5 halves. It's 2.5. If we canceled it like you wanted to, I'm like, ooh, what does that equal? Is that the same thing? No. So big old illegal maneuver here. You cannot cancel this out. Now, what you could do for giggles, if you really wanted to, is you could divide 3x by x, and you could divide 1 by x. You could. This is the same thing as 3 minus 1 over x. But that's extra. Would you want to do extra? No, just leave it like this then. Or a little or below it. So you could do that. Number 6. Now hold on, Coach Meidenbauer. You told me that I can't. For dividing, I guess I flip the fraction, but there's no fraction. What the heck do I do? Oh, it's over 1. Oh, can I flip that fraction? Yeah, into what? Oh, okay. And does anything factor at all? X plus 2, I think that's the only thing that factors. This actually is not a bad idea. If you just put parentheses around everything, it's a little more obvious, so you don't make illegal math moves. So you can only cancel parentheses or singled out terms. That's it. So what cancels out here? Bam, bam, you're left with x plus 2 over x plus 3. Put in parentheses if you want. You don't have to. It's your call. I'll just will for right now. It's cool or cold? I'm like about to sweat. It's really warm in here. Yeah, your opinion does not matter. Okay, what about this guy right down here, number 7? Nick, you want to try it on your own? Try 7 on your own. X plus 1, X plus 5? Yes? Coach, do I need to distribute that in FOIL or whatever I call it? No. Does it ask you to do that? Then don't do it. Okay? Just want you to do the division property and reduce as low as you can. Okay, number 8. This is just single terms. Everything here is a single term. Don't start canceling out now. What do you need to do before you start canceling? I don't know if I'm going. Do I go too slow through these, or am I going too fast, or just right? Okay. I mean, some people might be like, "You're going so slow." Some people might be like, "You're going too fast." Okay, so what cancels out here? Start with the numbers. Does 8 cancel out with anything on the bottom? Yeah, 8 goes into the 2. 4 is left. 2 is gone. What about the x squared? The squared goes away with this x. Bam. See you later. What about the y? Y is gone. And that square is gone. What about that 5? 5's gone. That 15 turns into a 3. Or imaginary 1. If you want to write a 1, you can. Bam, 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 bam. 4x b to the third over 3 ay. Alright, we go to multiplying and dividing. That's the easy part. Good job, dude. Okay, for adding and subtracting, you cannot do anything until you get that common denominator. That's where people will start messing up. They're like, the answer is 7 over 9x. No. 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 1/2 plus 1/3 is not 2/5. Okay? Alright? It actually got a lot smaller by doing it that way. So you need to get common denominators. Sometimes you multiply both fractions. Sometimes you need to do just one. In this case, what can we multiply to get these to be common? Which one by 2? Both of them? One of them? Just the left one? So times 2. And that's going to give you a 6. So you're going to get 4 over 6x plus 5 over 6x. Which is how many over 6x? 9 over 6x. Does this reduce at all?
Do we have to reduce it?
Yeah, these you have to reduce.
I thought we just said we didn't have to.
No, you see, when we cancel things out like this is called reducing. Like this, canceling out that is reducing. Just like when we canceled out this, we didn't leave this as 8 over 12. We reduced it. Okay? So we do need to reduce. So what's 9 over 6 reduced down to? Multiply by 3, so 3 over 2x. Number 10. Ooh.
What?
Ooh.
That was a good shot.
All right. Thank you. I appreciate the respect. I may or may not have a lot of experience of doing that. Okay, so let's look at number 10. What common denominators can I come up with? This one's a little bit trickier because there's so much going on. Let's start with the numbers. What common what? It needs to be a 15. Okay? How can we make that 5 into a 15? Each side's going to get multiplied by 3. I'm not going to do it yet, though. And then on this right-hand side, multiply everything by 5. I'm not going to do it yet, though. This one, I'll kind of just, it's hard to do the side work on this side like that. Okay, so what's the A's? What's my least common multiple for the A's? I don't want to just keep getting all of these A's because they're going to cancel out. But A squared is the highest A value. So the left side, how many A's do I need to multiply it by? Just one A. And the right hand side doesn't need anything. But in terms of the B's, the right side needs a B. Now everything's going to match up very nicely. So I'm going to get 6ax over 15a cubed b cubed plus 20. Oh, it's squared? Yep. This is why Daniel should teach class.
I said it.
Yeah, but we didn't make a comment about you teaching class.
Okay.
Now I need to make it to one fraction. Does anything cancel out when I make it to one fraction? No, let's just leave it. Well, nah. Actually, no, something does cancel out. And I'll talk about it real quick. Okay. Well, maybe it doesn't. I'll talk about it, though. Alright. You can only factor when you can cancel. Okay? Because you need to reduce this if it's possible. Only factor if you can cancel. Only factor if you can cancel. Is anything going to cancel if we factor? No. It looks like it could. What's the GCF on the top? A 2. Is the 2 going to cancel out with the bottom? So do I need to do it? So the final answer is fine. So these addition problems are different, and the subtraction problems are different. This first step is not the factor. We need to first get everything, well, I mean, that's kind of subjective. It could be the first step. But really, is I want to get common denominators, put them together, and then factor and cancel. Don't just factor, but factor and cancel. If you can't cancel, don't bother factoring. Me neither. Let's move on. Okay, for number 11, what's the common denominator? Yep, so x plus 2, x minus 2. So you need to do x minus 2 over here. X plus 2 over here. Now be careful. What do you get? This is a minus sign. We need to distribute that negative all the way through when we get to the right fraction. So on the left, we're going to get 3x minus 6. All over x minus 2, x plus 2. Minus 8x plus 16. And I did not distribute that negative sign yet. So the biggest boo-boo I'll see from most of you is this distribution, this negative sign, when we combine this into one fraction. Okay? Make sure that you distribute. So when I make this into one fraction, I have 3x minus 8x. Negative 5x. Negative 6 minus 16. Minus 22. Does anything factor and cancel? Some people are like, what about the x minus 2, x plus 2? I'm going to put those together. No, that's extra work. You can, but it's extra work. So don't do that. Are we cool so far? After this next problem I do, it's going to get very redundant. I'm just kind of warn you. Number 12. we need to get common denominators. Now, could we just multiply the left side by x squared minus 4x minus 12, top and bottom, and the right side by 2x minus 12, top and bottom? Totally could. If you want to, that's so much work. I agree. Do you need to do that? Is there an easier way to do it? What's the easier way? Factor first, see if they have any common factors. Do they have any common factors? That becomes 2x minus 6, and then this factors as x minus 6, x plus 2. Oh, that's kind of nice, because now the left, I only need to multiply the left one by what now? So x plus 2, top and bottom. And on the right side, I need to multiply that by 2. That's pretty nice. So I'm going to get 5x plus 10 all over 2x minus 6, x plus 2, minus 40. Get the sigh of enjoying math?
Yeah, I love math.
Perfect. Alright, so when I subtract this, what's my final answer going to turn into? Yep. Does anything factor and cancel? What factors and cancels? So I can take a 5 out of here. X minus 6. So x minus 6 cancel out. That's so nice. And then we're left with 5 over 2x plus 2. Fine. Okay. As I'm going through, we can start to chop off some of these problems if you want. Do I need to do 13, yay or nay? They already have common denominator, so you literally just make that negative m minus 3 over m plus 9. No big deal. There is one problem I haven't seen yet. I don't know if it's going to pop up, though. There's one concept. I haven't seen it yet. What about 14? Do we need to do 14? You just need to multiply the left one by 3, and then you're fine. So it's pretty quick. What about 15? Is that a good one? Why don't you try 15 on your own? That's a good one. That's a good solo one. Try 15 on your own. We're almost done. Then you can do a worksheet. Did you have a good nap, Shreyas? Good. Good. Alright, so how do we do? Sure. So I can get factor the bottom here. I'm going to get x plus 1, x plus 1. Factor this one, I'm going to get x minus 1, x plus 1. Sure. Okay. Now, there actually is a big old glaring shortcut here. A little different than we've been doing. You could go through and what's the left one missing that the right one has? It's missing an x minus 1. And then you distribute it all the way through. And then the right one is missing an extra x plus 1. And you can do all that. And actually, let's do it that way. Then I'll show you the other way to do it. And you'll go like, oh, you should have did that the whole time. So multiply this by x minus 1, this by x minus 1. Multiply this one by x plus 1, this one by x plus 1. This we do need to distribute, put together, and then see if we can factor and cancel. So when I do this, on the top over here, I'm going to get 3x squared plus 3x minus 3x, so that's kind of nice, minus 3 all over x minus 1, x plus 1 squared. You don't need to call it squared. You can do x plus 1, x plus 1. I'm just that lazy. I'd rather write it 2 instead of that. And this is plus, distribute that, you're going to get x squared plus 1. How nice is that? Or minus 1. Let's do this. X squared plus x minus 1. And this is going to be x minus 1, x plus 1, all squared. So combine everything on the top. What do I get? 4. 4x squared minus 4. X minus 1, x plus 1 squared. This is the top factor. It's 4 x plus 1, x minus 1. I kind of skipped a step there, because it's 4x squared minus 1, which factors again. So now it cancels out. Bam, 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 bam. 4 over x plus 1. I'll do the shortcut in red. Well, for this one, I thought I heard someone like murmur over it. Doesn't this factor on top as 3x plus 1?
Yeah.
So couldn't you just cancel that out right there?
Yeah.
And then, can't you just cancel out that with that? And now you're left with 3 plus 1 all over x plus 1. And then you're good. So if you ever get a chance to simplify those fractions before you add or subtract, do it. It's easier. But do you have to do that? No. Makes it a little bit easier. You want to give 16 the good old college try, last one, then we're done? Yeah. Because when I canceled this out with that, this just became a 3 from this fraction. When I canceled that out, you can't put a 0. It's a 1's its placeholder. And then you're good. Hey, real quick, before I go on to 16, there is like one problem I'm seeing that's missing that to me is important. Does this reduce this fraction? Yes, it does. What's the GCF on the top that you can take out to make it look like the bottom? So take out a negative 1, doesn't become x minus 1. So does it cancel out now? And you're left with? Just gotta be aware of that if you have complete opposite signs, they cancel out to be a negative 1. You want to try 16 on your own? Or want me just to do it for you because you're that lazy? That lazy, got it. Well, I mean, I have fun doing this, so I don't really care.
You have fun doing this?
Heck yeah.
There's some point in math where you just get tired of
Okay, so what's the left side missing that the right side has? An extra x minus 5. And what's the right side? X minus 4. So you're going to get x minus 5 over x minus 4, x minus 5 squared minus 5x minus 20 all over. Yes, but then that would bring us backwards.
Oh, okay. Oh, yeah, it would.
Okay, now you combine these. The reason that we don't factor this stuff initially is because we need to combine it. So I can combine it now. What's x minus 5x? Minus 4x. What's negative 5 minus negative 20?
Which would be plus.
Don't forget to distribute that minus on each of those. I know people will not do that, and that will not be good. Can I factor and simplify? Nope, done.